So welcome to the Red Hat Enterprise Linux Roadmap. This is our annual roadmap presentation brought to you by the RHEL engineering management team, and this year with the addition of our product strategy leader. We have a lot of information to share with you today. We've got a lot of wonderful things to announce. We're kind of excited. But first, the legal disclaimer, because RHEL 7 is not officially out the door, we have to remind everybody that things that we talk about in RHEL 7, there's no official commitment until the day that we actually ship. So what to expect in this presentation? I'm going to give a brief review of the life cycle and the status of every release, and the engineering managers are going to talk about their areas and the features that you can find that their guys have been working on for the last few years. As you can imagine, with RHEL 7 imminent, I love to hear that, RHEL 7 is imminent. As you can imagine, that most of the content this year is going to be focused on RHEL 7 and the things that we're going to be showing that are going to be showing up there very soon now. Because there is so much that we want to share about RHEL, we know there's never going to be enough time, even though this is a double session. So we try to make sure that we include pointers to all of the other places where you can find RHEL content. We actually have a whole Road to RHEL 7 track this year. And so we've got lots of demos over in the product area. So we've got included in the handout and in the slides, we've got pointers to other places where you can go when you want to do the deep dive into the information. Another thing that I want to make sure that you get out of this presentation is I want you to know the RHEL engineering management team. Yeah, smile, you guys. Come on. We're starting, because this is a double session, we're starting with 6. We'll do 6 and 6. Mm-hmm. So these are the faces that you want to remember so that you can corner them in the hallways and ask them all sorts of questions. We always run out of time in this session. And so, despite our best intentions, we never seem to get to the question and answer period at the end. But this year, because we have the Summit app, you have the opportunity to use the Ask a Question feature, and those will get collected and they'll go to us, and we'll be able to respond to you later on in email. So if you have questions along the way, use that feature on the app. At the end of this first session as well, we have some polling questions that we're going to ask you. So this is RHEL Engineering's way to try to understand a little bit more about what our customers are thinking. So the caveat, of course, is that we only have time to describe a subset of the proposed features. So please visit all of our other talks and do come see us at the demo stations because there are some really interesting demos this year. Docker. This first session, we're going to Lars Herman, who is our product strategist, is going to talk about the future of RHEL, our product direction. Linda Wang is going to talk about all the changes that went into the kernel. Rashid Khan is going to talk about networking. Tom Coughlin, file systems and storage. And Jack Reedon, system management and security. We'll do our polling questions, take a short break, and then go on to the afternoon part, which will be software collections and core utilities under Vashik. Karen Noel will talk about virtualization. Paul Frields will talk about the desktop. David Cantrell will talk about installation. There's a really nice Anaconda demo, by the way. And Matt Newsom will talk about developer tools. So I just wanted to start off with a little bit about how we create RHEL, because it's particularly relevant right now as we're getting RHEL 7 ready to go out the door. And clearly we don't do RHEL all by ourselves, right? Red Hat, we're open source, we're committed to working in communities and bringing innovation together. We do a I think RHEL 7 represents a lot of Red Hat's traditional strengths. We standardize, we stabilize, we put it all together, we curate, and we make it consumable for our enterprise customers. One of the things that we do as we work in the upstreams is we pick the packages that we think our customers are going to be most interested in. There's an awful lot floating around in the world of open source. There are thousands of packages in Fedora. We curate those. We pick the ones with the best upstreams. We pick the ones that our customers have been asking for. We integrate everything in Fedora. So if you ever want to see what's coming for the future, go look in Fedora. We have 2,500 plus source RPMs that are going into RHEL 7 out of thousands and thousands of possibilities. We do targeted development, which means that when we hear from customers that a particular feature is really needed, but there doesn't seem to be somebody upstream interested in working on that feature, we'll go and work with the upstream and do some of the development ourselves, send patches, right, the open source way, to make sure that the right things happen. Before we ship any release, we work really hard to improve the quality. So product management was a little squishy about me saying this, but we have closed 17,900 bugs, give or take a few, in the road to getting RHEL 7 out the door. So when you think about it, you can understand why it's taking as long as it does. We've stabilized the kernel, test, 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 fix, fix, fix. We've worked really closely with an awful lot of partners. So you've seen some of them. You'll see a lot of them out on the demo floors. Partners like IBM and HP and Dell, partners like Fujitsu and NEC and Hitachi, AMD, Intel. So we work with an awful lot of hardware partners, software partners, to make sure that RHEL gets tested in the really complicated hardware setups that enterprises demand. And all the way through, we work with Shaq and his team to make sure that they're validating the performance. We do performance runs, and we make sure that when we discover issues, we dig until we get to the bottom of the issue and get fixes back upstream, because everything we do is upstream first, because that's just the way we do it. Today, we've got RHEL 5. 5.10 is available now with 5.11 in development. It's our last RHEL 5 release. It's had a long run, great lifetime. We're actually kind of looking forward to putting it to bed. But if you like RHEL 5, we have lots of options for you, right? Because it can still. One of the things that containers enables is to take along your application and your user space libraries and bundle it up and put it in a container. So if you have RHEL 5 apps, clearly that's going to be a goal of ours going forward to make it possible for you to pull your apps along. Right? The application is king. That's what Paul said. 6.5 for our RHEL 6 stream. 6.5 is available now. We've got 6.6 in development. 6.6 is the release, still keeping up with new hardware. We've got lots of features going in. RHEL 7, the release candidate, is imminent. RHEL 8, yes, we're thinking about it already. And true confessions, we've been thinking about it for at least a year now. So if you want to understand what's going on for RHEL 8, go look at Fedora, because we're doing lots of innovation in Fedora. We experiment there, we try things out, and we figure out what's going to work, and then we pull it all back into RHEL. So I am really proud to announce that thanks to the efforts of the engineering organization and the QE team and our product management team and release engineering, we have a RHEL 7 release candidate that is going to be available next week. Yay! Yay! Come on, you guys. I can't believe it. Yeah, yes, we did it. So close. So thank you, QE. It's going to be available on the customer portal. So if you've already gone there and picked up the RHEL 7 beta that was out last December, you can go to exactly the same beta link And we're going to replace the pointer so that it gets you the release candidate bits. You can also get it off of the public FTP site. So there's a link here to the FTP site. You'll see an announcement coming out. We're really excited about this. If you liked the beta, you're going to love the release candidate. So now, I'm going to turn it over to Lars Herman.
Thanks, Denise. Can you hear me? All right, good. So my name is Lars Herman. As Denise said, I'm responsible for the product and business strategy for RHEL. And I want to use the next 8 minutes, 10, thanks, to talk a little bit how we think of RHEL, because RHEL has changed so much over the last 12 years. And I also wanted to share some insights how we approached RHEL 7 as the release that's imminent in the form of an RC, but then also beyond just RHEL. So to start a little bit with the history, building on what Paul said in his keynote this morning, we firmly believe that innovation in the industry, especially around infrastructure, is a story around Linux and open source. And as you can see, the history of Red Hat Enterprise Linux as the leading product in that category shows how we were building this out. It all started 12 years ago with Red Hat Advanced Server 2.1, which effectively was bringing Linux and open source to the enterprise for the first time and opened the door for building ecosystems and consumptions, replacing proprietary Unix, and unlocking a whole new wave of innovation around, at the time, the internet and the web. With RHEL 3 and RHEL 4, we've been maturing the platform to really get on par with Unix in many, many technology areas and features, so that Linux and Intel hardware became a first-class citizen in the data center and enabled innovation at a reasonable cost, at a high rate of change and pace. And building on this foundation, I think RHEL 5 marked a very, very significant milestone in the history. Launched in 2007, introduced virtualization for the first time. And that was at the time Xen-based hypervisor, but it was the vision of combining the application runtime and dependencies that developers use and that operations leverage in production with a long life cycle with security, with support, at the same time gets combined with the underpinnings to manage hardware resources, storage, network, and compute. So virtualization really was disruptive in the way of how organizations could deploy, deliver, and develop innovation in their environments and how they could exchange ideas. Literally, deployments went from weeks down to days or hours. Now, RHEL 6 added to this as really the platform for the mainstream. RHEL 6 was really when we had all the capabilities that were required beyond the more sophisticated early adopters or development-centric organizations to really bring Linux to the masses. And in parallel, of course, as an industry, we have seen the advent of service-oriented architectures, cloud, new business models. RHEL 6 was really providing the foundation for a lot of that innovation. Now, as we think about RHEL 7, that we really think of as the foundation for the open hybrid cloud. As Paul talked about this morning, in the open hybrid cloud requires a platform that allows applications to not only run very well in each of these different destinations, but actually also run very well in each of these destinations and maintain control with whoever needs to have control. It is the application owner who wants to make sure that he gets his features out of the door and delivered to his customers at the time when he wants it. It is the security team that watches out for security issues or maybe an OpenSSL bug that some people put a website up and then the press writes about it for a week. And it's equally, if you think about service providers who are increasingly providing the capacity for compute, for storage, for networking, they have their fair share of responsibility. All of these groups essentially work together to deliver business value to somebody. RHEL 7 is really designed to be the foundation to do just that. Starting with RHEL 5, we began to optimize Red Hat Enterprise Linux to work very well on bare metal. We work with our hardware partners very hard to enable their roadmaps and land the features and the hardware enablement in the product at the time when they want to go to market with new systems. We have been building out RHEL as a virtualization solution, later became Red Hat Enterprise Virtualization, as well as RHEL as a guest that is optimized on the leading virtualization and cloud platforms. And we have been putting RHEL out in the cloud and develop products that help customers to build clouds. What is really new this year, and you will hear a lot more about this over the next 3 days at the Red Hat Summit, is containers. Containers is really is something we've been working on for a long time. In fact, we did some research, and it all goes back to 2004 with SELinux and 2006 with C Group. So many, many years of innovation happening in the kernel, throughout the product, and now really coming together in RHEL 7 as the release, enabling that capability. We don't think of containers as an alternative to cloud or virtualization or bare metal. It is more an application delivery method that layers on top of these deployment methods, and that's why it's so important, because it provides the capability to ISVs, to development teams, to deliver their innovation, to deliver their releases on top of an infrastructure that's either existing or that's changing at the same time as companies go and adopt cloud, big data, mobile, and social infrastructure. Bring it back to RHEL 7. When we thought about RHEL 7 a couple of years ago, what do we think RHEL 7 is going to be? Then some people said it's going to be the cloud, and they were right. But it didn't really stop there, because in the end, it's all about the application. The application is king, as Paul said. So for the purpose of this session, we tried to categorize a little bit the many, many features in RHEL 7 or on the RHEL roadmap generally, and put them into 3 categories of applications to make it a bit easier for you to put features into context. So as we build out RHEL, we've really been able to expand its footprint into all these application categories that I'm talking about. On the left side of the chart with a little save icon, again, you will see these icons later throughout the presentation. This speaks to the mission-critical back-office applications. These are the applications that typically the life or death of a company depends on. These are the mission-critical ERP systems, the mission-critical business processes that just keep an organization running. Consequently, they are really like the pets in the pets and cattle analogy. A lot of love and attention goes into these workloads, very, very resistant to change or risk, and RHEL provides the rock-solid, stable foundation for these workloads. But it's not just about reliability. It's as much about performance, throughput, and scalability for these workloads, because often they are still delivered in a more traditional scale-up architecture, where any bottleneck anywhere on the stack slows down the overall output and limits the return of the technology investment. A lot of costs vary, and time is in the enterprise IT is actually spent on the middle category, which is not a particular kind of application. It's just the many, many, many hundreds, in most cases, of applications that enterprise IT happen to pick up over the years, often introduced to support a particular project or a particular business process, and these things just have a tendency to never go away again, so they become a legacy. And when we did research a couple of years ago around RHEL 7, we found that more than 80% of IT resources went into supporting these applications. So we felt, what can we do about these applications to just make it easier to manage them, to make it easier to deal with the complexity, to automate more how they get deployed, updated to new versions, and how does maintenance happen at the infrastructure level to serve these applications. So you will see a lot of features supporting specifically the vast complexity in these many applications. And then, of course, on the right side, we have what we call the systems of innovation. These are the applications that are delivering typically the highest degree of differentiation for the organization. Used to be called e-business. Now you talk about customer engagement or social or otherwise networking type capabilities, how an organization interacts with its customers, its partners, its prospects. These systems have their own unique characteristics. Typically, they're living on the bleeding edge when it comes to technologies. They're developer-led projects. Developers make all the decisions. Now, we all love developers. I'm sure many of us in the room are developers or have been at some time. But developers don't always make the best decisions for the long run. I think some of you can agree with that. So there's a particular challenge in combining the infrastructure for these applications in a way that they can be sustained in the long run. The other thing that I think is very unique about these applications, they're changing very, very rapidly. So just because something worked yesterday doesn't mean that it works 2 weeks down the road, because there are a couple more sprints and releases in the way. So we focused on enabling these applications and pave the path for organizations to get to the open hybrid cloud. Now, the last slide, I just want to level set a little bit. When we say RHEL, for the purpose of this presentation, what do we actually mean? Because RHEL is no longer just one product, one SKU, one price. RHEL is a whole family of offerings, as Paul explained this morning. On this slide, I tried to visualize how you could think of the RHEL family as a family of offerings that are optimized and designed for specific purposes. So we have been going as an industry from application enabling to application aware and now application optimized infrastructure. And there are actually RHEL offerings that match these use cases. There is RHEL Server as the lead offering, delivering the lifecycle security and stability that any application benefits from at the infrastructure level. Last year, we introduced Red Hat Enterprise Linux OpenStack Platform as a platform that not only runs RHEL application, but also that can orchestrate resources, that delivers software-defined infrastructure, compute, and also introduces the concept of multi-node scheduling and management for applications. Just this morning, we announced Red Hat Enterprise Linux Atomic Host as a new member of the family, delivering application-optimized infrastructure for containerized applications. Similarly, there are offerings at the lower line which are building on RHEL. They're basically embedding RHEL, they're delivering RHEL, Red Hat Enterprise Virtualization, cloud infrastructure, and ultimately OpenShift. So keep that in mind as we go through the rest of the presentation. When we say RHEL, we can mean any of these words because Red Hat integrates all these technologies and delivers them as a portfolio of offerings. Thank you. Linda, you would be next.
There we go. So my name is Linda Wang. I'm one of the kernel managers here at Red Hat. So I want to talk about RHEL 7 kernel architecture support. I'm going to go into a little more detail in some of the features we're putting into RHEL 7. First off, for RHEL 7, we're supporting the 64-bit architectures in x86 64, also PowerPC, as well as S390. Also with the 32-bit user space application compatibility support. In addition, we also set our theoretical limit on x86 64 in a logical number of CPU maximum of 5,120 logical CPU. And that is 5 times 1024 logical CPU, in case you're wondering where that 5120 came from. And also at the same time, where the maximum theoretical limit for memory, physical memory, is supported up to 64 terabytes. I want to also talk about I'm going to highlight some of the features, the core kernel features, and the enhancement we're doing in RHEL 7. There's a lot of features we're supporting. These are some of the features we actually lead, and a lot of the developers are leading these enhancements as well as basically participated upstream to get some of these features in. We are not only the kernel supports the mission critical back office application as well as in the area of performance enhancement. Also, we introduced and working on currently on dynamic kernel update feature, aka K-patch. We're also looking at enhancing some of the systems supporting your business process in the areas of performance tooling enhancement as well as debugging mechanism. In addition, we're also basically doing a lot of innovation in the area of resource management as well as Linux container, which Lars recently just mentioned. Well, I'm not going to go into a lot of details due to the time constraints, so I'm going to basically highlight some of the features here. And there's in the back of the session, the backup actually in session, and also in my talk, there's going to be references you can dive into and look up some of these features. First, let's get started with memory management. For memory management in RHEL 7, we switched from slab allocator to slot allocator. That actually provides efficiency of memory allocation as well as avoiding fragmentation. In addition, it's actually basically provides large scalability. We also introduced something called the fair zone allocator policy, which allows you, working with conjunction with K-swap-D, to actually better even out the memory allocation across NUMA zones for page reclaims. We're also working on SCED NUMA, which is now currently called the Auto NUMA Balance. It's a feature that moves the process closer to the memory that the process or task or threads are accessing, as well as it moves application data closer to the memory, the NUMA node that it's actually referencing. Lastly, but not last, we also have a couple more features as well. Trash detection-based feature for file cache. This is actually for big data sets that are using for basically mostly for application or data streaming as well as large data sets that you want to basically read once and basically put it into the file cache, and allows you to actually have a better way of balancing the memory applications for accessing large files. There's a couple more, I won't go into details. Next is also going to the scheduler. In scheduling and locking mechanism, in I/O scheduling in RHEL 7, we're actually in kernel putting in something that automatically detects what kind of storage device you have, and we're switching to the I/O scheduler you have. Best fit for that storage device. We'll automatically switch the deadline scheduler for I/O if you have an enterprise storage device. The default for the Linux kernel I/O scheduler is CFQ. Next, we're also introduced something called dynamic ticking, which is DanTick. That's actually basically allow you to lower the number of interrupts inside the kernel. And so basically give a lot of the CPU cycle back to the user space. Special benefits for KVMs, high performance computing application that has long running processes, as well as the telecom and financial applications. Those are actually some of the customer requests and partner requests that we introduce and trying to help. And we also switched the big kernel locks from smaller granular subsystem locks in 2.6.39. Next, and there are a couple more that we actually introduced as well. Also, in addition to all the features that we put in, we also have performance enhancement. We introduced something called jump label, which is to significantly reduce the overhead of enabling of trace, which is a tracing mechanism we have in the kernel. And in addition, we're also putting something called event pooling. We optimize by removing some of the global mutex, EP mutex, and replace it with a new algorithm, RCU for traversal. And also, that actually introduced quite a bit of performance improvement, 4 times as improvement for spec JBB, went up from 32K JBOPS all the way to 125K JOPS. We also enabled the frame pointer in x86-64, which allows more accurate backtrace. And there's many more. In addition, we also have introduced a lot of the features in enhancing a lot of features in the debugging, analyzing areas. In core dump analysis, in the KZ-KDOM, and also in the crash area, we are supporting the compression algorithm at LZO and Snappy. Also, we export mmap interface through /proc VM core, so you can faster for core dumps, for mmapping. One new feature we added is TuneD profile that are actually tuned to specific variants of the install that you have. It actually also integrated with the installer so that when you install the system, not only the TuneD daemons being enabled, the profile that's set to that particular variant, which is either workstation or server, is actually enabled as well. So once you finish installing your system, you actually have the variants that all the nice tuning setup is already being set for you. We also introduced a new feature called hardware error reporting mechanism, which is called HERM. It is actually new to RHEL 7. It is a new infrastructure refactoring and replacing the EDAC, which is the error detection and reporting mechanism. And that is basically, EDAC util is basically being maintained and deprecated in RHEL 7, which is replacing by RAS daemon. That's for mostly memory error detection. We also have adding a lot of the enhancement in performance monitoring in perf O profile, as well as in dynamic tracing and static tracing, which is in system tab for ftrace, ptrace, as well as trace command. Well, one of the things that we're actually currently working on is called dynamic kernel updates. Currently it's technical preview. The tool itself is in RHEL 7, but it's in technical preview state, the tool. It's actually mostly meant for mission critical customers who demand nearly zero downtime. They basically has also the need, not only have a very stable operating system running, but they also need to actually have a way to patch the running kernel. So we actually look around to see what kind of feature we can actually use and improve based on the upstream kernel. And we're looking at ftrace in the kernel infrastructure. There's actually three stage of basically patching the running kernel. For this particular feature. We're looking at in-depth analysis of the patch for feasibility, the first part. Second part was converting that patch into an insertable entity. And the next one, the last part, is inserting that entity into the running kernel. We also want to make sure that that particular feature is compatible with the existing kernel functions such as KZ, KDOM, crash, system tab module, as well as all the tracing facility like ftrace, ptrace, as well as performance monitoring for perf. In addition, we're also looking at preserving the K-patch state, so you have one single kernel base kernel. Once you apply those patches on top, after you reboot, you have the persistent cross reboot. When you boot up the next kernel, when you boot up the same version of the kernel, after reboot, you have the same patch being applied to your kernel. So I'm going to go into more detail in the maximum RAS session tomorrow at 2:30. And there's also a demo booth tomorrow at 11 o'clock. So last but not least, this is the system innovation. Kernel is the foundation for the Linux container. There's 4 building blocks. We're trying to, for Linux container, we're going to be fully supported in RHEL 7. And it has 4 building blocks, which contains control group, namespace, SELinux, and systemd. Control group is what we introduced in RHEL 6 timeframe. And we continue to support CPU set memory, block I/O, network, and network priority. And in RHEL 7 timeframe, libc group is being maintained but deprecated and replacing with systemd scope and slice, which is brand new concept. And in addition, the next, another building block for container is the namespace, which we're going to support mount, UTS, IPC for inter-process communication, as well as process ID and networking. User namespace, we're currently looking at for later releases. Jack Whedon is going to talk more about this user space, it's SELinux, systemd, and also Docker CLI, so I'll leave that to him. Learn more about the kernel. Feel free to attend some of these summit sessions. These are actually very good summit sessions to go through the Shaq and Larry talking about the performance analysis, the Linux container. Bob and Bahab, that's going to me, is going to be talking about Linux container a little more. And we're going into more detail on maximum RAS in tomorrow's afternoon session. And there's also the AutoNuma balancing session from bare metal workload from Rick. And there's demo booths down in the partner pavilion. Feel free to attend. And in order to learn more about the topics and kernel topics, feel free to engage the kernel community, such as lkmail.org, kernelnewbie.org, as well as actually, if you want to participate in upstream kernel development, feel free to actually download from the GitHubs for the dynamic update feature. And to learn more about up-to-date articles and read up on up-to-date articles on the kernel developments, feel free to look at the lwn.net, as well as the relblog.redhat.com. All right, next is networking by Rashid Khan.
That applause first was Linda, right? Not for me? Just want to make sure. Don't want to get credit. Hi, my name is Rashid Khan. Same spelling as Rathaf Khan, but no relation. See, only the older crowd laughed at that joke because the newer ones don't know what I'm talking about. But we move on. So I'm going to talk a little bit about networking, and I'll be the first one to admit that if anybody had any problems with heartaches or heart bleeds, that had nothing to do with me. So that's some other crowd. Okay, with that said, let's move on. So networking is getting more and more complicated. I'll be the first one to admit. And there's layers and layers and layers on top of networking that is being added day by day. That whole demo area is buzzing with SDN and virtualized networking. But we are trying our best to make RHEL make it easier to manage, config, and monitor networking. And we have done a lot of work for enterprise class solutions for networking management. Network Manager, appropriately named, is one of those features in RHEL that we have been working on. It provides full desktop support for desktop customers. It provides complete CLI support with things like bash and tab completion. And on top of that, it provides an in-between sessions called NM2E, which is more like a highlight and click kind of a setup. So we are trying our best to change it from a bag of parts to ease of use. And we have been working and concentrating a lot in making that happen for RHEL 7. If you have tried NM in the past and didn't quite fit your needs, I urge you to please try Network Manager again and see its capabilities. We have really worked hard to revamp it, took everybody's feedback, and all of our team worked very hard to make it much better and suitable for desktop customers, for headless systems, for server enterprise, and for in-between users who need a little bit of help, but not too much. Okay, moving along. So this is an example of Network Manager TUI. This is the same old like BIOS kind of a setting. It doesn't need a full X Windows setup. You just highlight and click, and it helps you through the set up all your networking needs. By the way, there's a demo. There was demos about this morning, but there's also demos tomorrow at 11 o'clock in one of the booths just across the hallway. Please feel free to come by, and we'll show you more of this in action. Next up is Team Driver. This is another one of the big features that we've been working on. This is for all about link aggregation. So for things like 40 gigabit Ethernet pipes, it's funny, I was having dinner with some hotshot in the Silicon Valley yesterday, and he was saying, was there ever networking support below 100 megabits per second? I'm not joking. This was an actual question. And I said, yes. So the thing is that everybody is so focused on megabits that they don't even know that it used to be less, or kilobits. But now 40 gigabits is everywhere. There are multiple links that people want. Some people are pushing us to have multiple 40 gigs show up as one link aggregated. And others are saying, hey, 40 gigs is just too much data. I need active backup support. So you might say link aggregation has been there for a while. It was called bonding. Rashid, what are you talking about? If you liked bonding, you will love teaming. The reason is that we moved the configuration and management into the user space and left the data path into the kernel space. So it's best of the both worlds. And we have, again, I'm going to repeat myself, but we have a demo across the hall tomorrow at 11. Please feel free to stop by, and we'll talk more about it. And it comes with a lot of Team Driver. Is one of the best features in the sense that we have a lot of documentation. We have a lot of collateral material. GSS has migration scripts. So if you like bonding again, you will love Team Driver, and we'll make it easy for you to migrate. OK, moving along. Another thing that we've been working on is PTP. Everybody has been using NTP. It has worked its while. But now with sub-millisecond or sub-microsecond precision that's needed for robotics, high-frequency trading, even high-end cars, all of this stuff needs very, very precise timing. And they all need precise timing with global clock sync. So PTP support is fully supported in RHEL, and it's available. I'll give you an example. Denise announced RHEL 7 release candidate available, and I'm very sure our stock went up because of the price. So that kind of precision needed for high-frequency trading. Oh, one more thing I wanted to mention on that is that this comes with a lot broad hardware support as well. So we have a lot of partners and customers that we worked with to provide hardware timestamping support as well. OK, so NFV, SDN, Open Daylight, all of these things about network virtualization. It was a big topic, a discussion. In the keynote addresses this morning, I forget the lady's name. She talked about it from Cisco. Paul Comier talked about it. So this open virtual switch enables all of that. I don't want to take all the credit about that, but this is one of the marquee features for RHEL 7. What it does is that getting the packets into the server was so 20th century, like been there, done that. Now it's all about getting the packet from that blue wire, from that Ethernet jack into the virtual machines. And for that, you need an intelligent switch running inside the server that can manipulate the packet and route traffic properly. And then on top of that, it is extensions to the top of the rack switch, and then to the router, et cetera, and then off we go. So it's being pushed upwards and onwards into the top of the rack switch and the router and the metro nets, et cetera. And also, it's being pushed into actual NICs and even to some extent to silicon, actual silicon. So this has extensions all over the place. It comes with a lot of broad support. Again, we have demos across the hall. We have it working with 40 gig devices, with a lot of overlay networking, VXLAN, GRE, you name it. The alphabet soup is all dumped on it, and it all works. And we want you to try it with RHEL 7. This is one of the features that RHEL enables for other Red Hat products also. So as I mentioned, SDN, cloud, OpenStack, Open vSwitch enables all of that. Okay. Next up, 40 gigabit cards, software, drivers, you name it. It's not going to be there. It's here and now. It's happening. We have demos that we can show you right now. So it's happening now. A lot of broad support from our partners. 40 gigabits we are supporting with all of the things that I mentioned, OVS, Team Driver, Network Manager, PTP, everything. So it's all bigger pipes and more complications, and we are trying our best to make it manageable and consumable for all. On top of that, the Starbucks of the world, the coffee shops, everything needs more Wi-Fi support. So 802.1ad support is now fully supported in Red Hat RHEL 7 as well. And I think I'm doing good on time, so I'm going to spend a little bit more time on this. So this is just an appetizer for the things that I wanted to talk about. We have a full session tomorrow at 11 where we are going to do more of a deep dive. This is all the other stuff that comes with RHEL 7. So a lot of support in security, a lot of diagnostics, a lot of TCP improvements, low latency, fast path, data networking, all of that, fast path networking. Too much to mention in this fit in this 10-minute slot, and I was just told that the music for the Oscars is going to start soon, so I'm going to make myself scarce. So there was demos this morning, and we talked to a lot of key people, so that's good. But there's a full session about 24 hours from now or 23 hours from now. I don't know the room number, but please stop by. We have a full session to talk about networking. We'll take your questions. We'll talk more about that. And also tomorrow at 11, we have demos for all this stuff. So please stop by. This was just an appetizer per se, and the entree is tomorrow. Thank you very much. Next up is Tom Coughlin to talk about storage and stuff. This is the clicker.
Hello, my name's Tom Coughlin, not the football coach, the manager for file systems and storage. So the overall strategy for RHEL 7, the areas where we put especially strong focus, we're on expanding file system choices, provide more opportunities for different file systems, enhancements in the storage stack. So we have flash storage moving from SSD to the PCI bus. We expect that trend to continue with new technologies moving ever closer to the CPU, providing very low latency storage devices. So that's an area that we've focused on. And then support for higher capacities across the whole range of file systems. And then finally, emphasis on improving the ease of use and management for storage within RHEL. So I'll cover those topics as we go through here. So RHEL 7, the default file system in RHEL 7 will be XFS. We still have support for ext4 and ext3 and 2. We have support for NFS as well as GFS2 for shared storage. The maximum file system sizes have increased as shown on the slide here. And then the last item here, ButterFS, is there as a technology preview in RHEL 7. The reason is because we still are seeing issues upstream with data corruption problems and also problems with handling corner cases like eNoSpace and recovering from RAID device resynchronization events and that sort of a thing. So bottom line is we set a very high standard and we don't yet recommend this for your enterprise data. So as I said, XFS replaces ext4. You can still use ext4. You just need to go into Anaconda and change the default. So it's still there, still supported. XFS is included in RHEL 7 for no additional charge. You continue to access it in RHEL 5 and RHEL 6 as a layered product, an add-on product. In terms of the overall NFS topic, in RHEL 7, we've completed support for the server side of NFS protocol version 4.1. This includes support for once-only semantics. This is based on TCP guaranteed delivery, as well as using the standard NFS port for both normal traffic as well as for callbacks. So these are features that people have been asking for, and they're now there in RHEL 7. Another feature in RHEL 7 is support for labeled NFS, and this underlies the ability to be able to do SELinux over NFS. And then finally, a new product offering within the NFS space is parallel NFS, PNFS. This is an architecture in which the client will access a metadata server, an NFS metadata server, and then using that information directly access the data servers, either file servers or block servers or object servers. So we have full support for the file system layout for the PNFS client, and then technical preview for object and block layouts. What we're doing here is working with our hardware partners to have them continue to make products available for those protocols, and when they're ready, we'll have support for that. They're tech preview now. So we have full support for the file layout, and then expecting longer term when the hardware vendors have provided support for object and block. The GFS2 cluster file system for supporting shared storage. We've added substantial amount of effort working with our partners in the database area, SAS, in terms of improving the performance of GFS. You should be able to see that in RHEL 7.0 quite readily. And then there is support in GFS2 for the Performance Copilot. You'll hear a little bit more about this in the second half of today's talk. This is a new tool that allows for real-time analysis of the file system performance, as well as logging the information so that you can review the performance after the fact and look back through previous data and analyze what happened. So we have that support in GFS2. Now, within the overall storage stack below the file system, we have support for new protocols. In particular, the NVMe driver is a new standard for supporting non-volatile memory on the PCI bus. So flash on the PCI bus can use this NVMe driver to get extra low latency, extra performance. And it's an industry standard. So we're working with our hardware partners on developing support for that new standard. We've doubled the speed for Fiber Channel. We've doubled the speed for SAS, working with our hardware partners to make sure we've got the support for their latest hardware. In the SCSI target space, we move from a user-spaced target to a kernel-based target, the LIO iSCSI target. Provides higher performance and more features. And then we've added another feature within the SCSI stack that has been long requested. This is the ability to dynamically react to events that occur on a SCSI device. So if you go into your external RAID array and you create a new LUN, there'll be a notification within the Linux I/O stack that that LUN has been created. And now you could run a script, or you could manually react to that by configuring the device and mounting it and so on. So this is support for the asynchronous SCSI events. Other events might be, for example, a notification that the hardware device has reached a thin provisioning threshold and you're about to run out of space. And you'll get a notification in the Linux I/O stack, and you can write UDEV rules to take action on that. Finally, we have a new tech preview for a LVM tiered storage device. Any block device can act as a cache for any other block device. So the typical scenario would be you would use a PCI flash device as a cache for spinning media. But any combination of devices can be used there. That's there in RHEL 7 as a technology preview. We expect to move quickly into making that fully supported, so that you can do tiering of the storage devices based on their performance. All right, the next couple slides here focus on storage management. Today, to manage your storage, you need at least two different interfaces. One is to go to the storage array at the bottom there and create a logical unit and present it to the operating system and do zoning and so on. And then you go over, you leave the storage management console and you go to the operating system management console and you run your LVM command line commands, and then you run your file system makefs, and then you mount the device or partition it and so on. So there's at least these two different disjoint management consoles. What we've done in RHEL 7 is two separate topics here that I'll discuss. The first on the left, there's a new tool called System Storage Manager. And what this does is it gives you a single interface with which to manage both the file system as well as the underlying logical volume manager. So with a single command, you can create a file system that's a certain size with a certain RAID protection, and it will take care of all the PV create, VG create, LV create, the makefs, and the mount command, all with a single operation. So we're trying to simplify this command line activity that you need to do. And you can take a look at System Storage Manager, go in, and you'll find man pages on Google and so on, and there's a demo in the pavilion. I'll be out there tomorrow as well. There's a mention about that later here in the slides. On the right-hand side at the bottom, we have a new capability, lib storage management. What this is an API that allows you to manage external storage. So now, from your operating system console, you'll be able to create a logical unit on the back end of a RAID array. So you might have some RAID array on a fiber channel SAN. You can create a LUN on that device and then configure it within the operating system and then put it into a logical volume group and then put it into a file system, all from the same management stack within RHEL, within the operating system. So this makes use of an industry standard known as SMIS that allows the operating system to communicate with the storage device in order to manipulate the back-end storage. So then LVM2 app, or also known as liblvm, is a programming API to allow you to do what you would normally do with the CLI. So again, allows you to build tools on top of this to manage LVM more directly and easier using a program interface. Blivit, similar, is a storage management library that's been taken out of Anaconda to allow you to create storage devices. And then OpenLMI, there are numerous talks about that during the summit. OpenLMI is a management interface that allows you to script the management of the system as well as remote control of a large number of systems. So with that, I will turn it over to the next speaker, Jack. I'm sorry, in your handout is this list of additional talks, and now I'll turn it over, okay?
So do I actually get 10 minutes? No. I didn't think so. Okay, I'm rushing through this quickly. My name's Jack. Software assurance. Certifications are obviously very important to us. Common criteria, FIPS, USGCP. I'm not going to go through all these, but they raise the bar as far as what we do for releasing a RHEL product. They force us to, or they put into effect the idea that there's a lot of rigorous testing, third-party analysis, code reviews, and at the end of the day, you've got a product that actually performs the way it's documented. This is important to us and also improves the quality of going forward. And if you've ever gone through a common criteria certification, you know that this is a very long and tedious process, and it's definitely worth it at the end. It's just painful to get there. Next, just real quick on 6.5 and some security updates. The NSA Suite B algorithms are now supported, and most notably, the ECC curves under Suite B are supported, and we're going through a FIPS validation of that at the moment. Shared system certs is a common centralized repository for your root certs to allow you to manage them in one place instead of all over the place. TLS 1.2, and now we have an improved SCAP 1.2 scanner, which meets the current specification specified by SCAP, which I'll talk about in just a second. Some of the features in RHEL 7 As Paul mentioned today, basically it's Microsoft and us in the data center, and of course, we have to be able to work with Active Directory. And how we're doing that is with identity management, where they have now cross-realm support and improved SSSD support with Active Directory. Also, we have basic directory or Active Directory integration. And what that really means is the idea is we're going to be able to have a RHEL box, drop it into a Windows domain environment, and it just work. No jumping through hoops or anything, or adding new packages or whatever you have to do. It just will work. And it's actually integrated now with Kickstart. So you'll be able to set these environments up very cleanly and work in a Windows environment. And of course, UEFI Secure Boot is supported. SELinux, I've got to ask, how many people know what SELinux is here? How many people are still turning it off? So for you guys, we have a new coloring book for you. It's Dan Walsh has worked years on this book, so no, it's actually really good. It goes through why you never want to turn this off and why you should actually have this in it protecting your environments. In fact, we were looking at turning off SENforce or SETenforce 0, if you guys know what I mean. But no, I'm kidding. But SELinux, we've done a lot of work on that to improve it. Labeled NFS, as Tom mentioned, I think is huge going forward. And of course, we've got an integrated SELinux Docker policy that we'll talk a lot about over the next week. And Firewall D is our ability to start moving towards a centralized managed firewall. And what's important here is the fact that you can actually change a filter or a rule and not have to restart all the flows in your box when you do that, which is huge. SCAP. So we've talked about this several times over the last 3 years now, and the idea here is you build a policy according to either a STIG or whatever secure hardening procedures you have, and you basically can run a scanner across your system to make sure your systems are conformant or compliant with whatever guidelines you have. And now we've actually included the SCAP workbench, which allows you to customize or tweak that policy that you've got. And with that, we've integrated this with the installer team in Anaconda. Thank you very much. And of course, it's in SELite 5, and we were getting tons of people asking about this and how it's integrated, and it will be in a future release of SELite 6. And the last statement, I jumped the gun. We have not got that cert yet. It was supposed to be here soon, but it is imminent, is what I like to use the word.
Real close now.
Real close. The Open LMI project, Linux Management Initiative, was started about a year and a half ago after talking to a lot of customers, and what they're looking for is or asking us to do is to improve the usability and the ease of use of Linux. And as you all know, that's a tough task. So this was started, and obviously we're following the standards here with the DMTF and SIM, and focusing on areas you'd expect. What's actually, I think, is very interesting is the LMI shell, and if you're familiar with Windows PowerShell, this is exactly the same thing. You're able to do complex operations locally or on remote machines with a very simplistic interface. Okay, I'm still doing it? Okay. Systemd. Who has not heard of Systemd?
Wow.
Wow. I assume you're all using it now, right? Okay, so we're actually very excited about Systemd. This is it's going to help us really take advantage of some of the core features that are coming up with RHEL and Linux. And that's integration with C groups, with dodev. The socket and debug activation is going to be huge for basically scaling out your containered environments. And also, it is compatible with System 5 and its scripts, and we've got a ton of documentation on how to migrate your RHEL 5 and 6 machines to this. And of course, we're going to be available to help you with that migration when you get to that point. General D is another major feature of Systemd, and that's giving us finally structured data in a centralized point that we can either apply filters to, or it's pretty much one place where we can centralize that data, aggregate it, push it out with our syslog to an external aggregator, and now you've got a real system that you can use here. Containers. You've heard a lot about this. You're going to hear about a ton about it this week. Linda mentioned it. The thing that I want to make sure people understand is containers isn't an operating system concept or anything. It's a group of operating system features that make it up. So you'll never find a system call that says container blah, blah, blah. And what's coming about is the fact of Docker and making that easier to use containers. So they're hiding the complexity of setting up the namespaces, setting up the C groups, and wrapping SELinux around it into a very simplistic interface. And Docker. I'm sure you guys have heard of this, and if you haven't, this is very exciting for us. We've been working with this team for months now with the upstream, and we have many Red Hat engineers working with these guys. This is a new way of looking at how we can package an application up in its runtime and put it into a containerized environment. It's giving you the ability for application portability, the isolation with the SELinux policy wrapped around it. And the image on the side here is to give you just kind of an overview of how this all fits together. Because you'll hear about all the different technologies. You hear about them, here's systemd, here's containers, but until you actually see the big picture of how this is going to be, how it plays out, I don't think you really grasp the importance of what's going on here. And I think I'm doing good on time. And so there's actually one slide that I do not have in here. I wish I would have got in, is the Project Atomic that Paul mentioned in his meeting earlier. Lars will be talking about this later today, and Colin Walters will be going through in depth on tomorrow evening at about 6:30. I think that's on here. But I encourage you to see every one of these talks. They're very good, and I think you'll enjoy them. Anything else? In references, you can find these. And of course, my team and all these teams will be around the demo pods. If you guys got any questions, please come by, because we're really looking forward to talking to you.
Okay. Thank you. Okay. So if you have questions, please, I hope you've been using the Ask a Question app on the button on the Summit app as we've gone along. But right now it's polling time. So we have a few questions that we want to ask you before break. Kernel updates are currently shipped every 8 weeks for our supported releases. We're looking at doing the same, putting all of the user space updates onto that same schedule. So we wanted to ask you all whether that was something that you thought would work for you. So yes, change user space to the same schedule as kernel goes on right now, or no, keep user space the way it is now, or I don't care. So if you can use your Summit app to answer this one for us, please. Yes. See, I told you. Change. So for next year, how can we improve this presentation? We've used the same format for several years now, but we want to make it better. So we can add more technical detail, or we can try to do more higher level feature overviews with benefits and use cases. We can add more product roadmap and strategy, or we can just keep it the way that it is. And the winner is? Oh, interesting. Okay. Okay, so last question. When would a lightweight, flexible container infrastructure like RHEL's Project Atomic be useful to your organization? Right this very minute? Within 6 months? Within 12 months? You've got no plans for any of this? Or what's RHEL Atomic? Huh? Hey. Okay, so thanks, folks. We're going to take a break right now, and when we return, we'll go on to the second half of this presentation. Thanks for joining us.